This is project 5, video number 2. It's time to code it up. So I have already fired up Octave. I'll go to the editor. And let's see what we got. Function ex equal to ex of x, and do some initialization. So let's try that. Function e underscore x equals ex of x. And so don't forget to end the function. Put the end in there. And had k equals 8.99 e9 times 10 to the 9th. A equals, I think it was 0.025 meters, and B equals 1 times 10 to the minus 6. And I think I'll save that for a while. And I gotta save it as ex. It puts the .m on there for me. I saved it as ex, and it's you can see ex.m has appeared. And let's I want to check those numbers. 0.025, 1e minus 6. Okay, and then e underscore x is 2 kb times 1 over 1 minus the square root of stuff. E underscore x equals 2 times k times b times the quantity 1 minus 1 slash square root of stuff. I think it was 1 plus the quantity a slash x squared and square root. So that's the square root of all that stuff, and that stuff is what I'm saying. Let's see. Just spaced it out a little bit so I could see it more easily. I think I will. Oh, I think I'm missing a... Yeah, that's for the square root, and then I need this parentheses. I think I'm good. Try a semicolon. And take a look at what the formula was when I wrote it out by hand. I think that looks good. Alright, that presumably does it for that function. I'm going to try Control S, go to the command window, and run it for some x, ex 0.01 for instance. I gotta plot it from minus 0.025 to 0.025, so this is in that range. And I get a positive x component. I want to try to the left of the origin. The electric field should be pointing away from the origin, so ex should come out negative. And I'm getting the exact same answer as what I had up there. So I think when x is negative, I would expect a negative answer. And so I think there must be a mistake. Yeah, this is saying ex. So let's see if I can get to the bottom of that. I think maybe what I want to do is use an earlier expression. It's interesting, when I divided both sides by that, I think it took away the sign information. So I'm going to leave that x there. that was this expression right here. I'm going to think about it. When x is negative, that makes this negative. And I think I have an issue. And one of the first things I want to fix is I notice I left out a parenthesis in here. Makes it hard to see what's going on. And I'm going to leave this. This is minus a minus. So this 1 over the square root of x squared, I'm going to leave it that way. For this position, and then minus, that's minus this piece. And I can write the 1 over the positive square root. I want to always be taking the positive square root there as the absolute value of x. Or I could leave it the way it is. I think I choose in the next line to write it as the absolute value of x. So I'm going to stick this back in here. I'm going to put a square root of the square root of x. I got to always take the positive square root, or else I lose my sign information, algebraic sign. And then this I'll fix up as instead of distributing that, dividing top and bottom by 1 over x as I did before, I'll leave this as 1 divided by square root of a squared plus x squared. So just to recap, this piece came from here. The minus and minus gives me a plus, 1 over the square root of x squared. And then minus this piece is right there. I think that looks good. And then I want to take the positive square root, and I get minus thing, and this makes it with the positive square root. If x is positive, this is going to be positive. If x is negative, then ex is going to be negative. Alright, so let's, I think I'll fix that here. So it's times x yeah, that's not looking readable. And yeah, let's go ahead and erase that whole thing. Alright, so I got a b there times x. Then I can just barely see it up there. I'll make it so I can see a little bit better. Times, could have gotten by with just parentheses there. I think I'll do that. So, times 1 over absolute value of x minus 1 over square root of a squared plus x squared. Alright, let's see if that makes more sense. It's a good thing I checked just to make sure I got the minus sign. So, try to fix it up over here. So times the x, and then times 1 divided by absolute value of x, abs of x, and then this was a squared plus x squared, I think. Take a look. Alright, I think that looks better. So Let's try that. Control S, command window. Try running it again. And then something wrong in there, big time. Line 5. So I got square root of the quantity a squared plus x squared, all divided into 1, and that being subtracted from 1 divided by the absolute value of the square root of x. Let's make sure I got absolute value is right. Absolute value of 5 is 5, and absolute value of minus 5 is 5, so that looks good. Let's see if I can read that whole message up here. So I'm going to go run that again, get the error message again, and now maybe I can see it. I'm going to have to maximize this window where you can't see it. Must be the subscripts must be either integers, 1 to that, or logicals. X of 62, it seems to be saying, in column 5. So, well, in row 5. So I left off the times. Alright, save it. Try running it again. Try running it with a positive value. And now I'm getting EX pointing to the right in one case, EX pointing to the left in the other case. So if I'm to the left of the origin, it should always be pointing away from the charge because the charge is positive. So I'm pointing to the left of the origin, EX should be negative, and it is. If I'm to the right, it's positive. It is symmetric, so if I'm the same distance, I should get that. I think, let's do a check. I think I'll go ahead and calculate the electric field at 0.01 by numerical integration. So let's take a look at the original integral is up here. I'm going to go ahead and plug it into my calculator, but I'll put I call it a check. So don't tend to show as much work on checks. Oh, that's not where I wanted it. No. That's kind of after I did the integral. I want to check by numerical integration. So I'm going to copy this down, make myself a little room from formula sheet. And erase this. So EX at 0.01 meters equals, this is just a check, so I think I'm going to put it in black, and I'm not going to show my work as clearly as I would if it were actually part of the calculation. So check EX at x is equal to 0.01 would be equal to 2, I'm going to put that all inside, integral from 0 to 0.025. And this is where I'm not showing my work properly. I'm just doing a check. I'm going to leave off the units. So that's 0 to 0.025 meters along the y prime axis. And I got a 2 times 8.99 times 10 to the 9th, and then times b, which was 1 times 10 to the minus 6. And I say I'm evaluating at x being equal to 0.01, rather arbitrarily chosen spot. This goes from 0. Ooh, they're all inside already, so I don't need that. I'm already inside the integral. So times y prime, which in my calculator I'm going to type in as x divided by y prime squared plus 0.01 squared all to the 3 halves, and then times dy prime. Eval numerically on calculator, and I get and of course it helps if when you're doing the check you can copy correctly that 3 halves should be inside here. So it's just the denominator being raised to the power of 3 halves. And when I do that, my calculator spits out 11302.396. That is in newtons per coulomb or volts per meter, whichever you want to call it. And that does indeed compare favorably with 11302 times 10 to the 4. We had 11302, and if I slide this decimal place over 4 and erase the times 10 to the 4th, I got 11302. So 11302 and then 0.3, so it rounds to 11.302. Okay, so as far as that being a check, I've checked that if this integral is correct, this expression for ex, if I didn't make any mistakes up until that point, then when I integrate it numerically on the calculator for the special position x is equal to 0.01, chosen arbitrarily, I get the same result as I got doing it analytically and then plugging the result into the computer. So it doesn't check everything, but it gives me a lot of confidence that this expression that I found for ex analytically is correct. So I've made some changes to what I produced in video number 1. That's why sometimes you have to look ahead, and it had to do with an algebraic sign issue. So this is my new version of ex down here. For positive values it turns out to be the same, but for negative values the negative sign inside this x here flips the sign of ex. And magnitude it always gave the same thing. And then I just want to make sure since I could have just referred to that equation, but I copied it down. Let's make sure I copied it down right. Yeah, I got the star x. And I might as well include that asterisk right there, since I chose to write this in terms of asterisks. So this is pseudocode. It doesn't have to be perfectly what you type into the computer, and it's pretty clear that it's not. Since I got this square root symbol and the absolute value symbol in there, but it was enough to make it so that I was able to get it into the computer program, and then had I put that asterisk there, I probably would have avoided a little bit of troubleshooting. But let's see how we're doing over here. I think this is the function, and we've had experience with this this x. When I go to use it for the graph, it's going to have 101 values. So this is multiplying a constant times that I'll call it array of 101 values. So that's okay. When I take the absolute value of it, I guess we'll have to check the units there, but I am. So I'm not. Let's see how taking the absolute value actually works out. I'm going to save that and create an X. I'll call it A. I don't know why, but I just feel like A, and I'll make it a linspace. 1, 5, 5 values. And actually I'll go minus 2, 2, 5 values. Alright, and then I'll try taking absolute value of A, that whole array, and see if it does anything fancy or just does what I think it should do. Yeah, it just takes the absolute value of each element in it. So this absolute value of X, that should work just fine. But when I go to divide, this is going to be an array of 101 values, so I need the dot slash instead of just the slash for that kind of division. And then over here, I need the dot slash instead of just the slash. For that, I'm a little concerned that it'll take it as a decimal point, so I'm going to put an extra space in there, but I'll also put the 1 in parentheses. So that dot clearly is part of the dot slash as opposed to that. Then this is A squared. A is just a number. That never changes. That's the 0.025. And this X, I need X dot to the power of 2 for the X squared. So I'll check and make sure it still works with just a simple number. And then I think I'll check and make sure it works with A. I'm going to make A have some negative values again. And then EX of A. So looks like a star is missing something. So I think it's this one. So I was good with constants up to there, but this star has to be a dot star. I don't really need spaces on either side of it. I just want to make sure that you realize it's dot star and not X dot and then times something. So I'm going to do a Control S, see if that works. And that's interesting. I got not a number for 0. I have to see how that plots. I think it's that business I've got. That's funny, the way it did the 1. This I can't do. In other words, this is going to be 1 divided by 0, whereas if I distributed that X, I would have it perfect. We're going to have to see how that works out. That not a number, we'll see how that plots in the graph. And actually what I can do is not have exactly 0 in my string. So I think it's fair enough to make little adjustments on what we got, but over here, I think if I went to the 100 values instead of 101, things will actually, I won't run into that. So I'm going to try 100 instead of 101. This, I'll show you what I'm talking about. chose 101 to make it look nice and neat, but this, I think, like the 51st value is going to be exactly 0. Whereas if I pick 100, it never hits 0, an even number of them. I think that's true. Let's take a look at that. I think I can get the same information by picking either 10 or 11. So again, you should, play with these things when you're not sure how it's going to work out. So I'm going to go that linspace thing, and I'll go minus 0.025 to 0.025, and I'll pick 11 values. And it includes 0, exactly 0. Whereas if I pick 10 values, it goes from minus 0.02 something to plus 0.02 something, so it straddles the 0, so I won't run into that not a number thing. So I'm going to use 100 there instead of 101. I think I'll go ahead and adjust that. So even in there, you don't really have to fix that for the pencil and paper part of what you hand in, but I'm going to change it so I don't put in 101. Don't run into that not a number. Might not be a problem, but glad I played around with it a little bit. Alright, let's try. I'll go to the editor. I'm going to try a new function, and let's see what I had in mind here. Function dummy graph EX of stuff. Function. No return variable, so I'll call the return variable dummy. I'm not really returning anything. And this is graph EX, and I think it took no arguments. I go end. I have to hit enter for that. And then it was x equals linspace of 0.025 comma 0.025. And give me 100 of those values between minus 0.025 and 0.025. And then probably E underscore X equals EX of X. And plot X comma E underscore X. And I think I'll put some semicolons there so it's not printing out 100 values. Control S. I think I want to graph. I'm going to type in graph. Gotta keep the name the same as the function name, graph EX. Alright, that looks good. Save it. I'll look at this other function. Make sure I got all the semicolons. And say when I was running that, did it print out? It just printed out the answer, so I think it should be good. So let's try graph EX. Open, close, and I get a graph. And to the left of the origin, the X component of the electric field is pointing in one direction, so negative values. And the closer I get to the line of charge, the greater the magnitude of that electric field. and then it jumps to another, and at 0.01 it looks like it's about 12,000, which, what did I get up here when I did the check? 11,300, so that seems reasonable. So that's actually working. I got to do things like graph and the plot. So this is a sudden jump from there to there. I think that's an okay way to display a jump discontinuity in a function, just a vertical line. I am kind of curious as to what would happen with that NaN, so I'm going to try 101 values. That was in the other function. Save it, run it, take a look at the plot. Oh wow. It jumps from there to there. I'm not sure which I like better, having that connected together by a vertical line or not. I think this is at least as good. So the line of charge is at x is equal to 0, and then along the y-axis, which is not depicted in this picture. And then as we approach it, we're getting closer and closer to the line of charge. I find it interesting, the x component of the electric field gets stronger and stronger. And then as we cross over the 0 position, big jump, and then it starts dying off as we go to greater and greater values. I think in between it's undefined. The business of having a number there that was printing not a number, it just made it so that the graph became discontinuous there. I think I like that better. So without that line in there, because it wasn't really quite vertical, because we don't go quite all the way up to there. I feel like I can see a noticeable space in there. So I think it'd be better if I use more points. Get to the editor, get to the graphing function. I'm going to try 1001 and do a save or run. Take a look at that graph. Yeah, then it looks like it's gone right up to 0. It's gone to within a thousandth of a meter of 0. And then it starts over on the other side of 0. So I prefer that. So we got a jump discontinuity at 0 in e sub x, because which way it's pointing switches as we move through the origin. So that looks like a reasonable graph. The number agreed up there. It is negative to the left of the origin, as we required. When I say the number agreed up there with at 0.01, I calculated it using a calculator. Oh, I can probably check it out even a little bit more closely. So that this tells me where the cursor is, 0.01. I'm looking down here at the numbers down here in the left-hand corner, and it very close to 0.01. I don't think I can get any closer there. But we're at about 11,000 something, and once again we calculated in the check 11,000 something, 11,300, and this is saying at 0.01. That's 0.01 comma, and then at 0.01, if I get the cursor really close to 0.01, but still on the curve, there's slightly over 0.01, 11,000. I guess it's 11,300. Probably not quite on it. So. So it agrees. I would say it agrees as closely as I can position the cursor there. And So this isn't spitting out anything extra to the screen. I think we're to the point where all we have left is documentation and finishing touches. Like we got to put axis title, graph title, unit, stuff like that on the graph. But this, as far as coding it up, I'd say we're done. So this represents a wrap on Project 5 video number 2.